my PU2 aspirants, so our final chemistry PU2 exam is there, and in today's video we are going to revise all the numericals, okay? And the best part of this video is all these numericals have been taken from your PU2 revised question bank of 24-25, okay? So the questions are mostly expected from this question bank, so we will be solving all the numericals from this particular question bank, okay? So I'll be telling you the important formulas, how to approach the question, how will you get marks, everything I'll discuss in detail, okay? So let's get started here. Yes, so what all things we will be having in this today's lecture? You can see we will solve almost 15 numericals from the chapter solutions, 20 numericals from electrochemistry and 15 numericals from chemical kinetics, okay? And all these questions, as I told you, has been taken from Government of Karnataka Department of School Education Pre-University Revised Question Bank 24-25, okay? Now, if you watch this video, what can you expect? You can expect full marks in section E. Now, full marks means, I mean 9 out of 9. Okay, you can solve all the numericals and you can get full marks in this particular section, and easily you can confirm this 9 marks. Okay, so now let's move to the first chapter, that is solutions, and our first question. So yes, calculate. So before moving to this, I want to just tell you how you should be approaching the numerical questions, okay? So there has to be 3 steps in a numerical question. 3 marks, 3 steps should be there. The first step, okay, step number 1 should be formula, writing the correct formula. Step number 2 is correct substitution. Okay, writing the correct values. Step number 3 is correct calculation and final answer. Correct calculation and final answer with units. Please remember, this is very, very important. If you don't write units, it will not be evaluated. Similarly, if you just write down the final answer without these 2 steps, then also you won't be getting any marks. Okay. Now, apart from these 3 steps, you will get 3 marks here. I also want you to write one step 0. The first step, when you read a question paper or a question, is to write the given values. See, this step does not carry any marks, right? But yes, you have to write the given values in the question, okay? So yes, now move to the next question here. First, that is question number 1. Calculate the molality and mole fraction of the solute containing 3 gram of urea per 250 gram of water, okay? So you have to calculate urea also, you have to calculate you have to calculate the molality as well as mole fraction, okay? So let us now write down. First, what all values are given to me? I have 3 gram of urea. So I can write weight of the urea. Oops, sorry. I can write weight of the urea is how much? 60 gram. No, sorry. That is 3 gram. 3 gram. Okay. Next, I have molar mass of urea. Molar mass of urea is already given to me, 60 gram per mole. Next, I have mass of water. So mass of water. So here you can give the short forms if you want to give. Like for example, mass of water, it is a solvent. I want to write it as W1, which is how much? 250 gram of 250 gram. Similarly, here for urea also I will write like this. From the beforehand I will specify what it is. So I can write like this, mass of urea. I'll write as W or 2 because it is solute, and that is equal to 3 gram. Okay, this is done. Next I have molar mass of water. Molar mass of water. And here also you can specify, this is M1, capital M1, and that is 18 gram per mole. And here I want to write this as M2. Okay, clear? Now we have step 0 is done here. Now step 1, first is to write the formula. Okay, so I want to write here mole fraction mole fraction of urea, that is equal to X of urea is equal to, okay, first let us do molality. Why? Because molality is given in the question first, so I want to write down molality first. Okay, so molality is equal to, I will write the formula here, number of moles of urea divided by mass of the water in gram into 1000. Okay, now I can write down the formulas in terms of symbol. So number of moles of urea will be W2 by M2, okay, into 1000 by mass of the water in gram will be W1. Okay, now substitute the values here. So I have W2 is equal to 3 by 60 into 1000 by 250. Okay, now if I solve this, I can calculate the molality value. Okay, now similarly you have here mole fraction, of urea, okay, that is equal to number of moles of urea by number of moles of urea plus number of moles of water. Okay, now what is number of moles of urea here? It is 3 by 60, okay, divided by 3 by 60 plus number of moles of water is we have 250, right? 250 divided by 18, given mass by molar mass, 250 by 18. Okay, so now if I solve this, okay, so how much I will be getting the answers? Molality I will be getting here 0.2. Okay, I can calculate like this also. This is 4, then I have 12, 5s are 1 by 5, that is 0.2. I will get here, and mole fraction will be getting is 0.0039. So you can check the calculation. Okay, so here the unit will be 0.02, 1 second, 0.02 m, and for mole fraction it is 0.0039. There is no units. You can put the final answer in boxes. Okay, next question number 2. If 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride, determine the mass percentage of carbon tetrachloride and benzene. Okay, this is very simple question. So I can first write down mass of benzene and mass of carbon tetrachloride. So 22 gram and 122 gram. Okay, now I have to calculate mass percentage. So mass percentage formula is, okay, whose mass percentage I want to calculate? Mass percentage of benzene. See, mass percentage of benzene is equal to mass of benzene by total mass of the solution. Total mass of solution. Now mass percentage of benzene is 22 grams divided by 22 grams plus 122 grams. Okay, so that is equal to 22 gram by, we have 144 grams. Okay, now if I solve this, I will get the mass percentage of benzene. Similarly, if I want to calculate mass percentage of toluene, carbon tetrachloride. Okay, so this you can easily do like this, 100%, okay, minus mass percentage of benzene. You can solve like this. So whatever value you get here, okay, I have some into 100 is there, into 100 is there, into 100. Okay, so once I calculate here, then subtract it from 100, you will get the values. So we can calculate here. So mass percentage of benzene is coming to as 15.28%. Okay, now here what I will do, 100 minus 15.28%, and that will give me 84.72%. Clear? This is fine? Okay. Next, we'll go to question number 3. These are very easy questions now which we are dealing with. The mole fraction of helium in a saturated solution at 20 degrees Celsius is 1.2 into 10 to the power of minus 6. So, I will write the first value. Mole fraction of helium is 1.2 into 10 to the power of minus 6. So, it's better always when you are writing for the first time, okay, please write down with the words, and there only you mention the symbol so that there is no confusion, right? I can write like mole fraction of helium, and I can mention like this, that is I am representing with this one, is equal to 1.2 into 10 to the power of minus 6. Okay. Next we have to find Henry's constant is given. So, Henry's constant, so in this way you don't have to explain the terms again in the equation, right? Henry's constant Kh is equal to how much? 144.97 kilobar. Okay, I have written the values. Next I have to write down the formula. So, formula as we all know, P of the gas is equal to Kh into X. So, I can write partial pressure of the helium. Question is asking about the partial pressure of the helium is equal to this much, which I have to calculate. Kh value is 144.97 into X of this one is 1.2 into 10 to the power of minus 6. So, if I solve this, I will get 173.964 kilopascal. Okay, clear? Sorry, kilobar. Kilobar. Okay, this is wrong here, it is kilobar. Okay, clear? Because this unit is in kilobar, right, and we haven't done any conversions here. So, this is your final answer. Here you can make a box. Clear? So, this one will give you 1 mark, this one will give you 1 mark, this one will give you 1 mark. Next question number 4 here. The vapor pressure of a pure liquid A is 40 mm Hg at 310 Kelvin. The vapor pressure of this liquid in a solution with liquid B is 32 mm of Hg. Calculate the mole fraction of A in the solution if the mixture obeys Raoult's law. Okay, so this question I can say bit tricky, but yes, not even difficult, but yes, little bit tricky question. So, first of all, what I can mention, the vapor pressure of pure liquid A. So, I can write vapor pressure of pure A is that is P naught A is equal to how much? 32 mm Hg. Clear? Next, calculate. Okay, one more thing, the vapor pressure of this liquid in the solution with liquid B. So, I can write vapor pressure of A, vapor pressure of A in the solution, right. So, I can represent it as PA, that is equal to, okay, sorry, this is 40, this is 32. Done? Clear? Now, I can write according to Raoult's law, because it is given that the solution obeys Raoult's law, right. So, according to Raoult's law, what is the formula? PA is equal to P naught A into XA, right. So, what is XA here? So, you can define where XA is equal to mole fraction of A, mole fraction of A in the solution. Okay. These two terms we have already defined, so no need to define. So, I can write now XA is equal to PA by P naught A, right. So, what is PA value? 32 by 40, so that is 0.8. Okay, what is the mole fraction? X 0.8. Okay. Next, question number 5, calculate the mass of a non-volatile solute, molar mass 40 gram per mole, which would be dissolved in 114 gram of octane to reduce its vapor pressure to 80%. Okay, so let us first write down the values. We have here molar mass of the solute, molar mass of solute, I'll denote as M2, which is given to me as 40 gram per mole. Okay, then which should be dissolved in 100 gram of octane. So I can write now weight of solvent, because in octane I am dissolving it. So weight of solvent, which is your octane, you can just write down weight of octane. Okay, and this is 1, and you also have to denote a number here, so that while putting in the formula you don't have too much time, you don't have to write at that time. So weight of octane I am denoting as W1, that is 114 gram. Okay, next molar mass of octane, molar mass of octane, again this is the same thing. If you calculate, you will get it is 114 gram per mole. Okay, so you can just show the calculation here. Octane is C8H18, right? So it is 12 into 8 plus 18, so that is 96 plus 18, and that is 114 gram per mole. Clear? This is done. Molar mass of octane is there. Now what else is given? The vapor pressure is reduced to 80%. Okay, so what I can say, the vapor pressure of solvent, pure solvent, sorry, vapor pressure of pure solvent P0, I can represent it as 100%. Okay, then vapor pressure of the solution, vapor pressure of solution, that is your P, that is equal to 80%. Okay, now if I want to write down the formula, what is it? P0 minus P by P0 is equal to XB. Okay, and XB is what? NB by NA. Okay, or you can just write down the terms here instead of this one, so that, see, you can just write down like this. What is your solute here? We don't know, right, what is the solute. So yeah, XB is fine here. XB is equal to 1 second. Okay, so I can write number of moles of solute by number of moles of solvent, and I know the solvent is octane. Right, now here also I can further write this one as WB by MB into number of moles of octane. Okay, I want all of you to represent all the terms here, whichever you have not explained. So XB is equal to mole fraction of the solute, mole fraction of solute. Okay, WB also we haven't mentioned. We should take W2 here. Okay, because I have taken, this is W2. Why? Because I have taken M2 here, right? So okay, I'll just change it. Okay, X2 is your mole fraction of the solute. Okay, right? So here I will erase this one. So W2, this is also W2, is equal to weight of solute. Okay, next what I have, MB, M2. So this one also I'll change all the notations to 2. Okay, and eraser, I'll write N of octane. In place of that I will write W1 into M1. Okay, because that I have already mentioned, that is W1 and M1. So now I will substitute P0 minus P, that is 100 minus 80 by 100, okay, is equal to W2 I have to find out, M2 I already have 40, right, into W1 is how much? I have taken 114 by 114. So if I just solve this, okay, I'll be getting as 8 grams. So you can see 20 by 100 into 40, okay, that is your W2. So if I just calculate, it will get 20, okay, this two I cancel, right? So 2 4s are 8, so I'll get 8 grams. So the correct answer is 8 grams. So you have to mention all the terms in the numericals, okay. Next, moving to question number 6, the vapor pressure of a 5% aqueous solution of a non-volatile organic substance at 373 Kelvin is 745 mm. Calculate the molar mass of the solute. Okay, this is also very similar question. So now you see the vapor pressure of a 5% aqueous solution. So when it is given 5% aqueous solution, I can say that weight of solute, or you can just mention it as W1 is 5 gram. Then weight of solvent, that is W2 is equal to 95 grams. Okay, now what happens? P naught value, you can write P naught, that is pressure of, vapor pressure of pure solvent is equal to 760 Sg. Then I have vapor pressure of solution, that is equal to 745 mm Hg. Okay, now we have calculate the molar mass of the solute. So we can again use the same formula. Here I will use one more thing, molar mass of the solvent, or I can write molar mass of solvent, that is water, will be equal to 18 gram per mole. Okay, now I have mentioned all the values. I can write delta P by P naught is equal to P naught minus P by P naught is equal to XB. Okay, or I can write here X2. Okay, here again I made a small mistake. Always remember, you have to use 2 for solute and 1 for solvent. Okay, and this I am mentioning as M1. Okay, so now if I solve it, X2 will be equal to N2 by N1, or you can write it as W2 by M2 into W1 by M1. Okay, now just substitute the values. What is P naught value? 760 minus 745 by 760, okay, is equal to W2. I have to calculate, right? W2 is already there. I have to calculate M2, right? So W2 is 5, M2 I have to find out, into M1 is 18 and W1 is 95. Okay, so just solve this and we have to calculate, like it will become 15 by 760 is equal to I'll get 18 by 19 M2. Okay, 5 1s are 5 9s are. Then if I solve this, I will get M2 value as, I'll get M2 as 48 gram per mole. Okay, clear? Next, question number 7. The vapor pressure of water is 92 mm of Sg at 323 Kelvin. 18.1 gram of urea is dissolved in 100 gram of water. The vapor pressure is reduced by 5 mm. Calculate the molar mass of urea. Again, the vapor pressure based question, similar question only. So you have to do what? You have here vapor pressure of pure water. So I can write down like vapor pressure of pure water, that is P naught is equal to 92 mm Hg. Okay, next, mass of the solvent. Again write down weight of urea, which is W2 solute, right? That is your 18.1 gram. Here only you can write down molar mass of urea, that is M2, which is 60 gram per mole. Next we have dissolved in 100 gram of water. So I can write down weight of water, okay, W1, that is your 100 gram, and you can write down molar mass of water, that is 18 gram per mole. Clear this one? Then vapor pressure is reduced by 5 mm. So I can have delta P, okay, delta P, or you can write down change in pressure. Change in pressure is equal to 5 mm Hg. Okay. Now we can calculate quickly, very easily. Delta P by P naught is equal to X2. Okay, because I am writing it in the form of solute, that is N2 by N1, and that is equal to W2 by M2 into W1 by M1. Okay, now I will substitute the values. So what is delta P value? 5, okay, and here P naught value is 92, right? 92, yes. Then here you can write down just the values, no need to write down the units while substituting here. Okay, next W2 is what? We have 18.1, okay, M2 is 60, into W1 is 100 grams, yes, molar mass is 18, okay. So I have to just solve it. One second. Okay, M2 we have to find out. We cannot substitute that this one is 60 gram, because that is what we have to calculate actually, okay. So we know, no doubt that we know the molar mass of urea is 60, but you should do the calculation and show that value. So if you solve this, you will be getting 59.9 gram per mole, which approximately says that the molar mass of the urea is 60 gram per mole, okay. Next, question number 8, calculate the boiling point of a solution containing 25 gram of urea and 25 gram of thiourea in 500 gram of chloroform. The boiling point of the pure chloroform is 61.2 degrees Celsius and Kb is equal to 3.63 Kelvin molal inverse, okay. So yes, this question is also, I can say, a bit tricky, okay. So please see properly what you have to do. Now you are having two solutes, okay, you are adding two solutes in one solvent. So that is why first what you have to do, you have to calculate the number of moles of both the solutes individually and then add the total number of moles, okay. So what first I'll do, I will write number of moles of urea, I'll write number of moles of urea, which are represented like this, that is equal to given mass by molar mass, so 25 by 60, okay. Next I will write number of moles of, okay, before that we should mention what all things are given, right? I forgot to do that. So first I will take mass of, one second. Okay, so first I have to write here mass of urea. Mass of urea is 25 gram, right? Yes, so I can represent this as Mu, or not Mu, I'll write Wu, okay, because for the given mass we use W and for the molar mass we use M, so Wu, right? Then I can write down molar mass of urea. Molar mass of urea, so that is Mu, 60 gram per mole. Then I'll write mass of thiourea, 25 gram, this I can mention as Wt, okay. Next you have molar mass of thiourea. Okay, molar mass of thiourea, this I can mention as Mt. Now this one will be equal to, so if you see 10 and 28, 29, 30, 31, 32, 32 plus I have 12 plus I have 32. Okay, so I will get 76 gram per mole, right? This is 76 gram per mole. Okay, next what I have here, okay, next what I can write now, number of moles of urea, number of moles of urea, that I am representing as NU, and that will be weight of U by molar mass of urea, so 25 by 60. Okay, similarly I can write down number of moles of thiourea, NT. Okay, so you can write down here WT by MT, and that is 25 by 76. Now if I write total number of moles, total number of moles, and that is equal to NU plus NT, that is 25 by 60 plus 25 by 76. Clear? This is done. Next what I have to find out, the formula, and what else data that is given to me, I'll write down here only the other datas. Boiling point of chloroform is T 61.2 degrees Celsius, so I can write down T naught B, that is 61.2 degree Celsius. Okay, and then Kb value is given to me as how much, 3.63 Kelvin M inverse, and I can also write W1, which is your mass of solvent, that is your 500 gram of chloroform, right? So now I'll put the formula here, that is delta Tb, which is equal to T naught B minus Tb is equal to Kb into number of moles of urea plus number of moles of thiourea into 1000. Okay, sorry, 1 second. Okay, into 1000 divided by W1, that is your mass of the solvent. Let me just a minute. Okay, give me 1 minute. Yes, so what I have here, number of moles of thiourea plus number of moles of urea, right, into 1 by W1, that is your mass of the solvent. So what is here, T naught B, sorry, it's not Tb, it's Tb minus T naught B. Yes, right? Okay, clear? So Tb I have to calculate. T naught B is given to me as 61.2, then Kb value is 3.63. Okay, next Nt plus Nu, that is 25 by 60 plus 25 by 76, okay, into 1 by W1 is how much, 500. Okay, not 1, we can take it as 1000, right, because our mass is in grams, so we can take it as 1000. Okay, so here also I'll put 1000. Just a minute, I'm with scarcity of space here, so I will write 25 by 60 plus 25 by 76 into 1000 by 500. Clear? Now you can solve this and you will get Tb value, which comes out to be 66.61 degree Celsius. Okay, so just put down all the values. So here the tricky part was to calculate the number of moles, total number of moles. How will you calculate correctly? Okay, next question, calculate the osmotic pressure in Pascal exerted by a solution prepared by dissolving 1 gram of a polymer of molar mass 1,85,000 in 450 ml of water at 370 degree Celsius. This is very simple question. So first let us write down the values. I have weight of solute, okay, that is W. I'll put weight of solute as W2, which is equal to how much, 1 gram. Okay, next I have molar mass of solute, molar mass of solute, which is M2, that is 1,85,000 gram per mole. Okay, next we have 450 ml of water. So I can write volume of solution, okay, or I can just write down V is equal to 450 ml. Next what I have here, temperature. Temperature in Kelvin will be equal to how much? 370 plus 273, so that is equal to 643 Kelvin. Okay, these are the units, these are the things that you have written. Now we will write the formula pi is equal to C into R into T. Okay, so what is here? You can just write down pi is equal to osmotic pressure, pi is equal to osmotic pressure, C is equal to molarity, okay, R is equal to universal gas constant, okay, next T is equal to temperature in Kelvin. Okay, now I'll substitute the values here. So pi I have to calculate, C is what? Molarity, so 1 gram by 1,85,000 into 1000, okay, by volume is 450. Next R value is 0.083, okay, temperature is 643 Kelvin. Okay, so now if I solve this, I will get around 64.106 kilopascal. Okay, so that is how you can calculate the pi value. Next, question number 10, calculate the concentration of that solution of sugar which has an osmotic pressure of 2.46 atm at 300 Kelvin. This is also very simple, you have to just calculate the concentration. Okay, so basically you have to calculate the concentration in terms of grams per liter. Okay, that is the trick in this question. So first of all, if I just write down the values that is given, so what is osmotic pressure? Osmotic pressure denoted by pi, that is equal to 2.46 atm. Okay, next I have temperature is equal to 300 Kelvin. Okay, next that's all, right? Now I'll write the formula pi is equal to C into R into T. Pi value is 2.46 atm. Okay, C value I have to calculate, R value is 0.083 liter atm mole inverse Kelvin inverse, temperature is 300 Kelvin. Okay, so now what is the value of C here? 2.46 divided by 0.083 into 300. Okay, now if I solve this, you will be getting the C in terms of what? In terms of moles per liter. Now if I want to calculate C in terms of grams per liter, okay, so just mention here that C is your concentration, right? So in terms of grams per liter, if you want to calculate, you just have to multiply with the molar mass. So 2.46 by 0.083 into 300 into that is 342 gram per mole, right? So here it is, this is now what? Moles per liter, this unit, this liter, this mole and this mole will get cancelled and we will have grams per liter, and the answer you will be getting here is 33.78 grams per liter. Okay, next question number 11, calculate the molar elevation constant of water, it being given that 0.1 molar aqueous solution of a substance boiled at 100 and 0.052 degrees Celsius. Okay, this is also very simple question. We know molality M, it is given to you 0.1 molal. Okay, next we have boiling point TB or boiling point of the solution, that is 100.152 degrees Celsius. Then I have T0 B, boiling point of pure water, that is equal to 100 degree Celsius. Okay, now what I have here, okay, delta TB is equal to T0 B minus TB is equal to KB into M. Okay, now what is T0 B value? So T0 B value is Okay, here a small mistake. Always remember, in boiling point, the boiling point of the solution is higher, right? So it is TB minus T naught B. So I can put 100 minus 152 minus 100, okay, is equal to KB into M is 0.1. Okay, so if I solve this one, this will be 0.152 divided by 0.1 is equal to KB, and that is equal to 1.52. Okay, Kelvin molal, or just you have to write M. Okay, so for molality is just M inverse. Okay, 1.52 Kelvin molal inverse. Clear? One second. 100.052. Okay, just a mistake here. This is 052, right? So I have taken wrong value. So please check your answers when you are doing this type of questions. Okay, so it will become 0.52 Kelvin mole inverse. Okay, next question number 12. The boiling point of benzene is 353.23 Kelvin when 1.8 gram of a non-volatile solute was dissolved in 90 gram of benzene. The boiling point is raised to 354.11 Kelvin. Calculate the molar mass of the solute. Kb of the benzene is given to you. Okay, similar question, boiling point based question. So first I will write boiling point of pure benzene, that is T naught B, that is equal to 353.23 Kelvin. Okay, next I have boiling point of solution, boiling point of benzene solution denoted as TB, and this is equal to 354.11 Kelvin. Okay, next we have Kb for benzene, Kb of benzene is equal to 2.53 Kelvin kilogram per mole. Okay, next what I have here, again 1.8 gram of a non-volatile solute. So I can write W2, right, non-volatile solute. I'll write the complete sentence, just a minute. Weight of non-volatile solute. W2 is equal to 1.8 gram. Okay, next I have 90 gram of benzene. So I have here molar mass of the molar mass of non-volatile solute. I'll write M2, and that I have to calculate. Okay, and what else is there? 90 gram of benzene. Weight of solvent, that is benzene, denoted as W1, is equal to 90 gram, right? Clear? So I have written all the values, I think. Okay, now I know this formula, delta TB is equal to TB minus T naught B is equal to molality, is equal to Kb into molality, and Kb into, for molality I can write down W2 by M2 into 1000 by W1. Okay, so now if I just substitute here, okay, so what is TB value? 354.11, okay, minus 353.23, okay, Kb value is 2.53, W2 value is 1.8 into M2 into 1000 by W1 is 90. Okay, now if I solve this and calculate the M2 value, you will get as 57.5 gram per mole. Okay, that is the molar mass. Next, coming to question number 13. A solution containing 34.2 gram of cane sugar dissolved in 500 ml of water froze at minus 0.374 degrees Celsius. Calculate the freezing point depression constant of water. Okay, so first slide down 34.2. So what is the weight of cane sugar? It is your solute, right? Weight of cane sugar, write down as W2. How much it is? 34.2 gram. Next I have molar mass of cane sugar. I can write down molar mass of cane sugar, right? That is, I will write as M2. Let it be 342 gram per mole. Next, what I have here, dissolved in 500 centimeter cube of water. So you know, for water the density is 1 gram per mole. So I can write down for water density is equal to 1 gram per ml, right? So mass of water is equal to density of water into volume, density into volume, and density is 1 gram per ml and this is 500 ml. So I'll get 500 grams. Okay, so I got mass of water here. Then the freezing point of the solution, I have here freezing point of solution is equal to minus 0.374 degree Celsius. Next I have freezing point of we can just write down freezing point of the solution. Just a minute. Yes, freezing point of solution is TF. This is freezing point of pure water is equal to T naught F, and that is equal to 0 degree Celsius. Okay, now you have to calculate the value of Kf, right? So I can write delta TF is equal to TF T naught F minus TF is equal to Kf into molality. So it is W2 by M2 into 1000 by W1, right? I have mentioned all the values. Did I mention? Yes, mass of water is equal to W1. Okay, now I can write down delta TF is 0 degree Celsius minus TF is minus 3.74. Okay, that is equal to Kf into W2 is what? 34.2 divided by 342 into 1000. I will wait just a minute. Let me write down it from little bit of the left side. I can start from here. So it is 0 degree 0 minus 0.374. Okay, that is equal to Kf value is how much? Kf value I have to find out, right? W2 is 34.2 divided by 342 into 1000 by W is 500. Okay, now if I solve this, I will get the value of Kf as 1.87 Kelvin mole inverse. Okay, now we will go to next question. The solution of urea in water has a boiling point of 100.128 degrees Celsius. Calculate the freezing point of the same solution. Molar constants for water Kf and Kb are given to you respectively. This is also a tricky as well as I'll say a very good question, means easy question but a little bit tricky question. Okay, so let us see that. You know that boiling point of water, boiling, 1 second. Okay, so I'll write like this, boiling point of water. Okay, so it is boiling point of water is T naught B is how much? 100 degree Celsius, right? Next I will write boiling point of urea solution, that is TB, is how much? 100.128 degree Celsius. Okay, this I got. Next I have freezing point of the water. Okay, next I have freezing point of water, that is T naught F, 0 degree Celsius. Next I have freezing point of urea solution, TF I have to calculate. Okay, these things are over. Next I have here KF is equal to 1.86 degree Celsius and KB is equal to 0.512 degree Celsius. Okay, now if I have here delta, what I have to calculate? Freezing point of the solution, right? Delta TF by delta TB is equal to TF minus T naught F is equal to T naught B minus TB is equal to KF by KB. Okay, so just substitute all values. So now TF I have to calculate, right? T naught F is 0 degree Celsius divided by TB. Again here I made a mistake. Please don't repeat. Always remember, in freezing point there is depression, right? And in boiling point there is elevation. Okay, so what will happen? So I will get an equation like this. So it is T naught F is 0 minus TF I have to calculate. TB value is given to me 100.128 minus 100, okay, is equal to KF is 1.86, KB is 0.512. Okay, now solving this one will give me, how can I solve it? Okay, so I have this one is 0 minus TF is equal to 0.128 to 1.86 minus 0.512. So if I solve this, I will get TF as the freezing point of the solution as minus 0.465 degree Celsius. Okay, now we will go to the last question, and yes, this question is a tougher one, or I can say not a very easy question. It will take time to solve this question, so you have to see the question properly. So the question is saying two elements A and B form compounds having formulas AB2 and AB4. Now when dissolved in 20 gram of benzene, 1 gram of AB2 lowers the freezing point by 2.3 Kelvin, whereas 1 gram of AB4 lowers it by 1.3 Kelvin. The molar depression constant of benzene is given 5.1 Kelvin kilogram mole inverse. Calculate the atomic masses of A and B. So here we have two cases. Okay, so what first I will do, let the atomic mass of A is equal to A. Okay, let the atomic mass of B is equal to B. I'll write first this one. Okay, next what I have 20. So next I'll talk about AB2. Okay, so what is weight of AB2? That is W2 is equal to 1 gram. Molar mass of AB2, molar mass of AB2, that is your, I can write A plus 2B, okay, denoted as M2. Okay, then weight of benzene W1 is equal to how much? 20 gram. Okay, next what I have here, okay, lowers by 1.3 Kelvin. Okay, no, lowers by 2.3 Kelvin. So I can have that delta TF is equal to 1.3 Kelvin. Okay, and what is KF value? KF value is 5.1 Kelvin kilogram mole inverse. Okay, so here I have this formula, delta TF is equal to KF into M. Okay, next I can put delta TF is 1.3. okay, KF value is 5.1. molality, or I can just expand this formula like this, KF into molality is W2 by M2 into 1000 by W1. Okay, now W2 is how much? 1 gram. M2 is A plus 2B, okay, into 1000 by W1. W1 is 20. Okay, so this is one equation that I will get. So if I solve this equation, I will get A plus 2B is equal to, okay, here a small mistake, this is 2.3, right? So this is 2.3. So if I solve this, I'll get A plus 2B is equal to 110.86. Okay, so just keep this equation like this. This is your equation 1. Okay, now similarly what I can do is I can do for AB4. Okay, so what is weight of AB4? I can write W2, that is 1 gram. Okay, molar mass of AB4, okay, that is M2, that is A plus 4B. Okay, next we have weight of benzene, that is also 20 gram. Okay, next I have delta TF is equal to 1.3 Kelvin. Okay, next I have here KF value is also given to me, that is 5.1 Kelvin kilogram mole inverse. So I'll solve it in the next page. Okay, so just a minute. Yes, so I have one equation, just I'll write that first equation, A plus 2B is equal to 110.86. now the second equation, that is for AB4, I got is 1.3 is equal to yes, 1.3 is equal to KF, that is 5.1 into 1 by A plus 4B into 1000 by 20. So if I solve this, I will get A plus 4B is equal to 196. Okay, so now I have two equations, and A plus 2B is equal to 110.86. Now if I solve these two equation 1 and this is equation 2. Now if you solve this equation, you can find the value of A and B, and you will be getting A as you will be getting A as 25.59 and 42.64. A will be around 25.59 and this is 42.64. Okay, so this will be the answers, or the atomic mass you can write down mu. Okay, so this as the way you have to solve this question. A little bit lengthy question, but yes, you can practice similar question. It can be asked in the exam because it is there in your question bank. Okay, so now we will move to the next chapter, that is electrochemistry, and we'll be seeing 20 questions from this chapter. Okay, so let's continue. Okay, so students, now we are going to solve the questions from electrochemistry. Okay, so these questions have also been taken from your PU2 question bank, the revised one. Okay, so if I see the first question here, the resistance of a 0.01 normal solution of an electrolyte is 100 ohm. Calculate its conductance, conductivity, resistivity. The cell constant of the cell is 1 centimeter. Okay, so fine, this is also I feel very easy and direct question. So first of all, what is conductance? Conductance is inverse of resistance. Okay, so I can say that, see, conductance denoted by G is equal to 1 by R. Okay, so and we have been given with R is equal to how much? 100 ohms. So I can simply write 1 by 100 ohms, and that is equal to 10 to the power minus 2 ohm inverse. Okay, so that is your conductance. Clear? First one, A. Next, B is conductivity. Conductivity is what? So if I have this formula, R is equal to rho into L by A, right? So kappa, that is 1 by, that means what? 1 by rho, I can write it as 1 by R into L by A, and 1 by R is nothing but kappa. So I will write 1 by R into L by A. So now what is 1 by R value? So that is your 10 to the power of minus 2, and this is 1. So I will get 10 to the power of minus 2, okay, and that is your ohm inverse, so S centimeter inverse. Next, C is what? You have to find out resistivity. So resistivity is again inverse of conductivity, or 1 by K you can write down. So 1 by 10 to the power of minus 2, and that is equal to 10 to the power of 2, okay, and this one will give you 1 by R, right? So this one will give you ohm, so I can write ohm and then centimeter. Clear? So these are the answers, very easy and directly you can find out. Next, question number 2. For the standard cell Cu to Cu2 plus and Ag plus to Ag, E naught of copper is given as 0.34, E naught of silver is given as 0.8 volt. Identify the cathode and the anode as the current is drawn from the cell. So you can see here the left side part is always the anode and the right side part is always the cathode in a cell notation. So here I can write which is anode. Anode is copper and cathode is silver, okay. Now coming to the second one here, write the reaction taking place at the electrodes. So at anode what we will have? Cu2 plus 2 electrons gives you Cu, and at cathode we have Ag plus 1 electron gives you Ag, okay. Next, calculate the standard cell potential. So when you have the standard cell potential, so I can write E naught of the cell is equal to E naught of cathode minus E naught of anode, right? And what is the cathode here? Silver, whose value is 0.8, and anode is 0.34, okay. So I will have now 10 minus 4, 6, 7 minus 3, 4, so 0.46 volt, okay. So we'll get this as the answer, you can see here, okay. Next, question number 3. Calculate the potential of the hydrogen electrode in contact with a solution whose pH is 10. Yes, this is an NCERT in-text question and this is an important question as well. So if I just write down the hydrogen equation, it is 2H plus 2 electrons gives you H2. This is the equation, and the next equation for this one, and what we have another information is, see, if the pH is 10, then concentration of, so if you remember here, pH is equal to minus log of H plus concentration. pH is given as 10, so minus log of H plus concentration minus 10 is equal to log of H plus concentration, and 10 to the power of minus 10 is equal to H plus concentration, okay. So I can write here E of the cell is equal to E naught of the cell minus 0.059 by 2 log of 1 by H plus square, okay. So here E of the cell we have to calculate, right? For hydrogen, E naught of the cell is 0 because it is taken as a reference electrode. 0.059 by 2 into log of 1 by H plus square is 10 to the power of minus 10 square. So if I take this to numerator, we will get log of 10 to the power of 20. Right? Now this one can be taken here. I can write this is minus 0.059 by 2 into 20. So it will become minus 0.59 volt. Okay. So we will get this as the answer. Next question number 4, calculate the EMF of the cell in which the following reaction takes place. E naught of the cell is given. This is very direct and Nernst equation question. So I can write here E of the cell is equal to E naught of the cell minus 0.059 by 2. Why I am writing 2? You can see nickel to nickel 2 plus 2 electrons, 2 Ag plus to 2 Ag, again 2 electrons, log of Ni2 plus divided by Ag plus square. Okay, so this one will give me E naught of the cell is 1.05 minus 0.059 by 2 log of nickel 2 plus is how much? 16 into 10 to the power of minus 2. Then Ag plus is 2 into 10 to the power of minus 3 square. Okay, so if I solve this, we'll get 1.05 minus 0.059 log of, okay, so I can write it like 8 and this, sorry, this is 4, right? 1 second. So I will just square it and write, so 4 into 10 to the power of minus 6, right? So I'll just write down 4 into 10 to the power of minus 6. Okay, so I will get here 4 into 10 to the power of 4, right? So if I solve this, you will get 1.05 minus 0.059 log 4 is how much? 0.602, and this is log 10 to the power of 4 is log 4. Okay, so just solve this one. So I will get how much? 1.05, right? I have forgotten this 2, I think. Okay, here it is by 2 by 2, 0.059 by 2 into 4.6. Okay, so just solve this, you will be getting around 0.91 volt. Okay, next, coming to question number 5 here, the cell in which of the following reaction occurs, calculate the standard Gibbs free energy and the equilibrium constant of the reaction. This is very simple formula based direct question. So Gibbs free energy, we have delta G is equal to minus NF E naught of the cell. It is minus, electrons are 2 into 96500 into E naught of the cell is 0.236 volt. Okay, so if you calculate, you will get delta G value. Next, what I have here, next thing that I can calculate is the equilibrium constant. So for equilibrium constant, you have E naught of the cell is equal to 0.059 by n log of K. Okay, so E naught of the cell is 0.236, 0.059, okay, by 2 and log K value. So if I solve this, you can find the value of K. Okay, clear? After solving this, you can find Gibbs free energy will be around minus 45.5 kilojoule. Okay, and this K value will be 10 to the power of 8. Okay, just a minute, just let me check. Okay. Okay, so let us see this calculation. Okay, I think this calculation is easy one. So if I just take multiply this one, 0.236 into 2 by 0.059. Okay, so you can see here I can multiply 2 6 are 12, 2 3 are 6 plus 1 7, 2 2 are 4, 0.472 by 0.059. Okay, so I can see 8 9s are 72. Then I have 8 5s are 40 plus 1 47. So I will get 8 here. Okay, so this is what 8 is log K. Then K will be equal to 10 to the power of 8. Okay, so that is why I will get this one. Okay, next question number 6 here. The molar conductivity of 0.025 mole liter inverse methanoic acid is this much. Calculates its degree of dissociation and the dissociation constant given the lambda of H plus and the lambda of HCOO minus. Okay. So first let me calculate the molar conductivity of HCOOH. So we have molar conductivity of H plus and we have the limiting molar conductivity of HCOO minus. So this one will give me H plus is 349.6, okay, and this one will give me 54.6 S centimeter square mole inverse. Next, if I add this one, I will get 6 plus 6 12, 9 plus 1 10 plus 4 14, 5 plus 4 9 plus 1 10 and 4, right? I'll get 404.2. No, sorry, I have done wrong addition here. Just a minute. 6 plus 6 12, 9 plus 1 10 plus 4 14, then I have 5 plus 4 9 plus 1 10. Yes, 404.2. okay, I'll get 40. S centimeter square mole inverse. This is what? Degree of this is your lambda naught m. Now degree of dissociation formula is what? Lambda m by lambda naught m, right? So lambda m value is given to you as 46.1, right, divided by 404.2. This will be your alpha value. Next, you also have to calculate the dissociation constant. So that is equal to C alpha square. So the C value is 0.025, okay, and alpha value is this one, 46.1 divided by 404.2 square, okay, C alpha square. So if I solve this, you will be getting as 0.114 and this one as 3.67 into 10 to the power of minus 4. You can easily do the calculation using your calculator. Next, question number 7. If a current of 0.5 ampere flows through a metallic wire for 2 hours, then how many electrons will flow through the wire? So yes, this is an important question and you can say little bit tricky question. So we know that Q is equal to I into T, okay. So I is 0.5 ampere, right, T is 2 hours, 60 minutes, 60 seconds, okay. So I can just write down 2 5s are 10, it became 1, so I have 3600, okay. Next, you have to calculate how many electrons. So I have Q is equal to N into E, number of electrons into charge of 1 electron. So number of electrons, that is 3600 divided by 1.6 into 10 to the power of minus 19, okay. So if I solve this, I will get 2.246 into 10 to the power of 22, okay. So just you can check this calculation. So I can do sum of bit. So I can write like this, divided by 16 into 10 to the power of 19. So 4 4s are 4 9s are 9000. Then I think I can divide it by 4 1s are 9000 divided by 4. So I'll have 4 2s are 8 1. So again 4 2s are 2 2250 into 10 to the power of 19, okay. Then I can write it as 19 20 21 22. So I'll get 2.25 into 10 to the power of 22. Here a small difference is coming because I have taken it only 1.6, okay. The actual value is 1.67. So if you do calculation, you can take the exact value. Next, coming to question number 8 here. The resistance of a conductivity cell containing 0.001 m KCl solution at 298 Kelvin is 1500 ohm. What is the cell constant if the conductivity of the cell is 0.146 into 10 to the power of minus 3 S centimeter inverse, okay. So we have to calculate the cell constant, right, conductivity. So I have this formula, right, R is equal to rho into L by A, or I can write it like 1 by rho is equal to 1 by rho is equal to 1 by R into L by A. Now 1 by rho is kappa, that is equal to 1 by R into L by A, okay. Now you can write down 1 by, what is R value? R value is 1500, okay, and the conductivity value is, okay, let me make it simple here. We have to find the cell constant, right? So I will do a better calculation. So I can write in like this. See, cell constant is L by A, that is equal to R by rho, or you can write R into 1 by rho is nothing but kappa. So just substitute the values here. R is 1500 ohm, right, and kappa is 0.146 S. S means I can write ohm inverse and centimeter inverse. Okay, so now if I multiply these two, you will get 0.219 centimeter inverse. Clear? Okay. Next, question number 9. How much electricity in terms of Faradays is required to produce 20 gram of calcium from molten calcium chloride? Okay. So if you see here, Ca2 plus 2 electron gives Ca, right? So I have suppose 2 Faraday can deposit 40 grams, right? So I can say 40 grams. One second. Yes. So I can say 40 gram can be deposited by 2 Faraday. So if I have 20 gram, that means half. So it will be deposited by 1 Faraday, right? So the answer for first one will be 1 Faraday. Now coming to the second one, you have 40 gram of aluminium from Al2O3. So if you see here, aluminium is in +3 oxidation state, right? So aluminium +3 electrons will give you aluminium. So I can say here that 27 gram is deposited by 3 Faraday, right? Then 40 gram will be deposited by 3 by 27 into 40, right? 1 gram will be 3 by 27, 40 gram will be 3 by 27 into 40. So almost it is 40 by 9. So 4.44 you will get, right? So that is here, you will get 1 Faraday, and this is 4.44 Faraday. Okay, simple and easy question. Next, a solution of nickel nitrate is electrolyzed between the platinum electrodes using a current of 5 amperes for 20 minutes. What mass of nickel is deposited at the cathode? Molar mass of nickel. So molar mass of nickel was actually not given in the question, so I have given you. So please remember this molar mass, okay? It was not given in the PU question bank, so I don't know whether it will be given in the exam or not. Generally it should be given, but to be on the safer side, you can remember this value. Okay, now coming to Faraday's first law, we know M is equal to Z into I into T. So Z is equal to what? Z is equal to molar mass, right, divided by N into 96500, okay, into I into T. Now coming to the value here, so nickel mass we have to calculate how much it is getting deposited. So 58.6 divided by 2 into 96500 into I value is what? 5 amperes. Then I have 20 minutes into 60 seconds. Okay, so if I solve this, I will get around 1.825 gram. Okay, so what is the value here? 1.825 gram. Clear? Okay, next question number 11. An electric current of 100 ampere is passed through a molten liquid of sodium chloride for 5 hours. Calculate the volume of chlorine gas liberated at the electrode at NTP. This is important question. See, electric current of 100 ampere is passed through a molten liquid of sodium chloride for 5 hours. So we have given, so I can say that if I see chlorine, 2Cl minus gives Cl2 plus 2 electrons, right? So I can say that 2 Faraday or 2 into 96500 coulombs deposits 1 mole of chlorine, right? Then 1 coulomb will deposit how much? 1 by 2 into 96500 mole of chlorine, right? Next, what I have here? I have this one, 100 ampere and 5 hours. So what is the amount of charge here? I into T, right? So I is how much? 100 ampere. T is 5 hours, 60 minutes, 60 seconds. So how much I'll get? 5 6 are 30, 30 6 are 180, right? 5 6 are 30, 36 are 180, and 1 2 3 4 3 4. Okay, so this is the amount of charge now I have. So 1 8 1 2 3 4 5 1 2 3 4 5. So this one will give me 1 by 2 into 96500 into 1 8 1 2 3 4 5. Okay, so these many moles were present. Now to convert into gas, what you have to do, just multiply it with 22.4 liter. So if you solve this, you will be getting around 208.91 liter. So why did I multiply it with 22.4 liter? Because we know that at NTP 1 mole of a gas occupies 22.4 liter. So that is why if these many moles are there, it will occupy this many liters. Okay. Next, question number 12. In an electrolysis experiment, a current was passed for 5 hours through 2 cells connected in series. So this is a question from Faraday's second law. The first cell contains a solution of gold salt and the second cell contains a copper sulfate solution. 9.85 gram of gold was deposited in the first shell. If the oxidation number of gold is +3, find the amount of copper deposited on the cathode in the second cell. So we have this formula C, mass of copper deposited by mass of gold deposited is equal to equivalent weight of copper by equivalent weight of gold. Clear? Now if I write mass of copper deposited, that will be equal to equivalent weight of copper by equivalent weight of gold into mass of gold. Okay. Now if you remember, what is equivalent weight of copper? Equivalent weight of copper, that is 63.5 divided by 2. Now what is equivalent weight of gold? That is 197 by 3, right? The molar mass divided by the n factor, the charge that is required. So here we have 63.5 divided by 2, and here we have 197 divided by 3, and into mass of gold deposited is 9.85 gram. Okay, so if you solve this, we will get mass of copper deposited. Now the mass of copper deposited will be 4.76 grams. Okay, just you have to solve this and check the calculation. Let us see the next question now. How long has a current of 3 ampere to be applied through a solution of silver nitrate to coat a metal surface of 80 centimeter square with 0.005 centimeter thick layer? Density of the silver is 10.5 gram per centimeter cube. So when this type of question is asked, you have to first find out the mass of the silver that is required to coat this particular metal surface. Okay, so how will you calculate the mass? So first let us calculate the volume. Okay, so what is volume? Volume is here 80 centimeter square. Okay, and here it is 5 into 10 to the power of -3 centimeter thick. So what I'll get here, 5 8s are 40, 400 into 10 to the power of -3 centimeter cube, and that is equal to, I can say, 0.4 centimeter cube. Okay, now volume is there. Now we have density is equal to mass by volume. So I can easily calculate the mass here. Mass will be density into volume. So density is 10.5 and volume is 0.4, right? So if I just multiply, 4 5s are 20, 4 zeros are 0 plus 2, 4 1s are 4. Okay, so I have 2 decimal places. So it will be 4.2 grams. Okay, so to deposit this 4.2 gram of the silver, how much current is required? So after this we can follow the normal Faraday's law. So I have M is equal to Z into I into T. right? Mass is how much? 4.2 gram. Z, silver mass is 108, right? And silver deposit N value is 1,96500. Current is how much? Current is 3 amperes, and then you have to calculate T from here. Once I solve this and calculate, I'll get T value as 125.09 seconds. Okay, so you should be knowing how to calculate this one, otherwise the question is very simple one. Okay, next question number 14. A saturated solution of silver chloride at 20 degrees Celsius has a conductivity of 3.41 into 10 to the power of minus 6 s centimeter inverse. The conductivity of water used was 1.6 into 10 to the power of minus 6 centimeter s centimeter inverse. Determine the solubility of the silver chloride moles per liter. Okay, molar conductivity is also given to you. Okay, now this question I can say is a bit tricky question. Okay, so first of all, what we have to do is we have to calculate the molar conductivity of the silver. Sorry, we have to calculate the solubility of the silver, okay, of the silver chloride solution. Now we have been given with the conductivity of the silver chloride and the conductivity of water. So from here I can calculate the conductivity of only AgCl, means without water. So that will be what? Conductivity of AgCl solution minus conductivity of water. If I subtract this one, I will get the conductivity of only AgCl. Okay, so now if I just substitute this one, what I will get? This is your 3.41 into 10 to the power of minus 6 minus 1.6 into 10 to the power of minus 6 s centimeter inverse. So now we can solve it. I have 1.6, right? So I can have 14 minus 8, 6, 2.81, I think. 1 plus 0, 1, 6 plus 8, 14, 2, 3, 4, sorry, 1.81. I am little weak in calculations, so please forgive me. Yes, this is the answer, or this is the conductivity of pure AgCl. Now what we have, this molar conductivity formula, kappa into 1000 by this C, and this C is nothing but your solubility that we have to find out. Now we have molar conductivity value, we have kappa value, we know 1000, and just we need to calculate the C value. So if I just substitute the values here, lambda m is how much? 138.3 s centimeter square mole inverse. Then here I have kappa value 1.81 into 10 to the power of minus 6 s centimeter inverse into 10 to the power of 3 divided by C. Okay, so if I solve this and calculate, I'll get the value of C as 1. Okay, just a minute, let me erase this one. I'll write it there, but if you solve it, you will be getting 1.31 into 10 to the power of minus 5 moles per liter. Okay, so do not worry, I'll write this here. Okay, so that implies here I can write C is your 138.3. okay, that is equal to 1.81 into 10 to the power of minus 6 into 10 to the power of 3 divided by C. Clear? Okay, next moving to question number 15 here. Calculate the quantity of electricity that would be required to reduce 12.3 gram of nitrobenzene into aniline if the current efficiency of the process is 50%. Now, if the potential drop across the cell is 3 volt, then how much energy will be consumed? Okay, so this is also very, I can say, tricky or a difficult question, so you should be knowing how to solve it properly. If you haven't solved this question before, then you cannot do it in the exam also. So first of all, nitrobenzene. See, this is nitrobenzene and you want to convert it into aniline. So basically what has happened, 2 oxygens have been replaced with 2 hydrogen. So 2 oxygen will come out, right? And this 2 oxygen should be converted to water. And if you know that for 1 oxygen we need 2 hydrogen to convert it into water, right? If 2 oxygens are there, I have to add 2 hydrogen here, 2 hydrogen here. To make it, this one I'll convert it into water and this one also I'll convert it into water. So I need 4 hydrogen, right? Again, this 4 hydrogens have been used to convert this oxygen to water, and to replace this oxygen with 2 hydrogen we need total 6 hydrogen. I hope this is clear. 6 hydrogens are required. 2 hydrogens will be used, oxygen will be removed and hydrogen will be coming, and 4 other hydrogens will be required to balance or to convert this oxygen to water molecules. So now I can write the equation like this. 1 second. Yes. So I will add 6H plus 6 electrons. So here this will go, this will come, and we will get here 2 water. Okay, so this is the equation here. Now the question is asked, calculate the quantity of electricity that would be required to reduce 12.3 gram of nitrobenzene into aniline if the current efficiency for the process is 50%. Now this part is important. So nitrobenzene, if I just calculate, what is C6H5NO2, right? C6H5NO2. So what is the mass here? 12 6 72 plus 5 plus nitrogen is 14, oxygen is 32, right? So just if I add 4 5 6 7 8 plus 5 13, here 1 7 plus 1 8 9 10 11 12, 123 grams, right? So I can say that, see, I can say that okay, I can say that for 123 gram of nitrobenzene, how much I required? 6 Faraday. Okay, 6 Faraday is required. Now for 1 gram I will require 6 by 123, and for 12.3 grams, for 12.3 grams I require 6 by 123 into 12.3. Okay, so that is equal to 0.6 Faraday. This is clear. Now see, if I want 0.6 Faraday, if I am providing 0.6 Faraday to this solution, actually this solution will get how much? 50% efficiency. Means if I am giving 0.6 Faraday, it will get 0.3 Faraday. So to get 0.6 Faraday, I have to give 1.2 Faraday, right? Half of it. How much ever I will give, half of it will be used in the reaction. So I calculated that, okay, for this reaction 0.6 Faraday is required. Now if I give 0.6 Faraday, because it is only 50% efficient, 0.6 half is 0.3. So we will get 0.3 in this reaction. But if I want 0.6 Faraday, I have to provide 1.2 Faraday. Now half of that will be 0.6 Faraday. So how can you write that? Since the current is 50% efficient, we have to provide 1.2 Faraday. Now what you have to do? You have to, quantity of electricity means charge. So the charge required will be 1.2 into 96500 coulombs. This you can multiply and find out the value. Okay. Next question is, if the potential drop across the cell is 3 volt, how much energy will be consumed? Okay, so energy consumed will be equal to the potential drop, okay, potential drop into the quantity of electricity. Okay, so how much I will get? Potential drop is 3 volt, right? Quantity of electricity is 96500 into this is 1.2 Faraday. Okay, so if I solve this, we will get it. So you can see here, this one is 115800. If you solve this one, energy consumed is EMF into quantity of electricity. So that is 3 into 96500 into this one. So you can just say, if you multiply this one with 3, you will get this value. Okay, I hope this is clear. This question was little difficult one. Question number 16 here. 2 students use same stock of zinc sulfate solution and a solution of copper sulfate. Okay, 2 students use same stock solution of zinc sulfate and a solution of copper sulfate. The EMF of one cell is 0.03 volt higher than the other. So they have used the same stuff of copper, but same stuff of zinc, but different solutions of copper. Okay, Now this is also, I'll tell, a difficult question, but you can solve it even if you haven't studied the question before. Okay, that is the thing. The EMF of one cell is 0.03 volt higher than the other. The concentration of the copper sulfate in the solution with a higher EMF value is 0.05. Find out the concentration of the copper sulfate in the other solution. Okay, so now see, we have two, just I'll draw first what I'm thinking. We have two solutions. Okay, first I'll write E1 is equal to E0 minus 0.0. So okay, just a minute, let us, so I'm writing these all things to explain you. So the reaction is like this: Zn gives me, okay, Zn plus Cu2 plus, I'm writing here 1, okay, gives me Zn 2 plus Cu1. Okay, so now here in the second one I have one more case where I have Zn plus Cu2 plus 2 gives Zn2 plus Cu2. Okay, so now basically what is the reaction? Zn2 plus concentration is same in both the cells. Okay, so suppose here I write E1, okay, that is E0 minus point, here I have to take 0.6 by 2 log of, okay, log of Zn2 plus concentration divided by Cu, here it is 1, 2 plus concentration. Okay, so suppose this one is the one with lower value, okay, and this is the one with higher value. Okay, so this is the equation I'm getting. Now similarly for here I will get E2 is equal to E0 minus 0.06 by 2 log of, okay, here I have same Zn2 plus concentration divided by Cu2 2 plus concentration. Okay, so here Cu1 and Cu2, let me write down outside so that you don't get confused here. That is Cu1 and this is Cu2. Okay, now it is the higher value is how much high? It is 0.03 volt high. So I will subtract these two equation. Now see, if I subtract E2 minus E1, okay, so what I will get? Please understand carefully. I'll write first this value, E0 minus 0.03, 0.06 by 2 is 0.03 log of Zn2 plus by Cu2 plus 2, okay, minus I have this value E0 minus 0.03 log of, okay, and I have Zn2 plus minus Cu2 plus concentration 1. This is clear. Now what will happen here? See, now what we can do, you can say this E0 value and this E0 value will cancel out, right? Now if I further expand, this E2 minus E1 value is how much? 0.03. Okay, 0.03 is equal to minus 0.03 log, I'll take this minus 0.03 as common, then here I can write it as log Zn2 plus C. Log A by B is what? Log A minus log B. So log Zn2 plus minus log of Cu2 plus 2, the second one. Then here what has happened, since it has minus is there, so this equation has actually become plus now, right? And if I have taken minus common, so here I have to keep this minus, okay, so that minus minus will get plus. So I have again log of Zn2 plus, okay, log of Zn, okay, I may confuse you, I will write all the steps here, okay, so that you don't get confused at all. Just a minute. Okay, so see, now what is happening here? Now I have got here, this is minus 0.03 log of Zn2 plus by Cu2 plus 2, okay, then here minus minus plus, then I have 0.03 log of Zn2 plus divided by Cu plus 1, okay, Cu2 plus, sorry, this is there. Next step what I will do, I'll take this minus common, okay, so let me see, 1 second, okay, just a minute, I will erase this part. This part is clear, I think, so I will erase this part. Just a minute, we will be solving it step by step. Okay, so this is, as I said, is little calculator based question, but a very easy question as well. You don't have to do much calculation here. Okay. Okay, now let us see. Okay, now what we can do is, see, I'll have 0.03 is equal to minus 0.03 log of Zn2 plus divided by Cu2 plus 1. Okay, sorry, Cu2 plus 2. Now here I will take this minus 0.03 I have taken as common. Okay, and this one also okay, I'll write like this. I have taken minus 0.03 common, so here it will be minus log of Zn2 plus divided by 2 plus 1. Clear? Now I have to write, see, this one I can cancel easily. I can write minus 1 on this side, and this one if I expand, that is this minus has come, so I can expand like this, log Zn2 plus log A minus log B, so minus log of Cu2 plus 2, okay, minus, here also log A log B, so log of Zn2 plus, then see, then I have to write, just imagine it is like this, log Zn2 plus minus log Cu2 plus, here this minus is there, so minus minus will become plus, right? So I am removing this one and I am directly writing here plus log of Cu2 plus the first one. Okay, clear? Now what I can do, I can cancel this one and this one, right? And I have this minus log A plus log B, means I can write log B log A by log B. So how I can write this one? So I can write log of Cu2 plus 1 by Cu2 plus 2. Okay, now I'll erase this lower part so that just a minute. Okay, so now if you see, so please do this question with me. Okay, start solving with me so that you don't get doubt. So yes, this is there. So we have now this side minus 1. So now if you see that this value, okay, this value is how much? Cu2 plus of the higher is 0.5, right? So I can write minus 1 is equal to log of Cu2 plus 1 by 0.5. Okay, taking antilog on both sides, it will become 10 to the power of minus 1 is equal to Cu2 plus 1 by 0.5. Multiply this one, I'll get 0.05 is equal to Cu2 plus 1. So the concentration of copper in the cell in which the EMF was lower was 0.05 molar. Okay, that is the answer. So yes, you can do this calculation. I have given each and every step. You can skip certain steps, then also that will be fine. You don't have to like divide and show each and every step as I have done. Okay, next question number 17. Okay, show that 0.08 molar solution having conductivity equal to 2 into 10 to the power of minus 2 has higher molar conductance than 0.1 molar solution having resistivity equal to 58 ohm centimeter. Okay, this is very easy question, just have to solve it. Okay, so let us see. Okay, conductivity is given for case 1. If I see, conductivity is how much? Concentration is 0.08, right? 0.08 molar, and here I have this one 2 into 10 to the power of minus 2 s centimeter inverse. Okay, then here I have second one where kappa is equal to resistivity is given. Kappa will be opposite to resistivity, so or inverse of resistivity, so it is, I can write s centimeter inverse, and molar concentration here is 0.10. Okay, so if I calculate molar conductivity here, it will be 2 into 10 to the power of minus 2 kappa into 1000 by 0.08. Okay, so it will become 20 by 8 into 10 to the power of minus 2. Okay, so if I solve this, it is like 4 2s are 8, 4 5s are 20, 5 by 2 is 2.5 into 10 to the power of 2, or I can write 250. Okay, 250 s centimeter square mole inverse. Okay, now coming to this one, here I can find molar conductivity as kappa, that is 1 by 58, okay, into 1000 by c, that is 10 to the power of minus 1. Okay, so now what I will get here, 10 to the power of 4 divided by 58. So just let us calculate here, 10 to the power of 4 divided by 58, right? So I can have, it ones are 58, 10 minus 8, 2, you have calculated, you can quickly do, right? But I don't have calculator, so I have to solve this one. So 8 8s are 64, 8 5s are 40, 7 8s are 56, 7, yeah, I can try 7 here, right? 7 8s are 56, 5 7 5s are 35, plus 5 40. So I'll get 10 minus 6 14, then one more time, then I think I'll take 3 2 8s are 16, 2 something it will come, right? So I can say 172 point something. You can do the calculation properly. So definitely you can see that, so that 0.08 molar solution having conductivity equal to this one has higher molar conductance. Yes, definitely this is having 250 molar conductance, it is 172.2. So that is how you can show this. Next, question number 18. The molar conductivity of acidic solution at infinite dilution is 390.7 ohm inverse, or you can say S centimeter square mole inverse. Calculate the molar conductivity of 0.01 molar acetic acid given that the dissociation constant of acetic acid is 1.8 into 10 to the power of minus 5. This is I can say a little bit difficult question because you should be remembering all the formulas. First, let us note down the data that are given. Molar conductivity of acidic solution at infinite dilution means lambda m is given, right? How much is this one? 390.7 S centimeter square mole inverse. Next, what I have, calculate the molar conductivity of, so what is the concentration? 0.01 molar. Okay, given that the dissociation constant of the acetic acid, so Ka equal to 1.8 into 10 to the power of minus 5. Clear? These all things are given to us. Anything other thing is given? No. We have to calculate what? Conductivity of this solution. Okay. Now see, what formulas I know, let me first write down those things. So I know one formula is alpha is equal to lambda m by lambda naught m, right? So, okay, I have to find not kappa, I have to find the molar conductivity. This is molar conductivity at infinite dilution, right? I have put this naught and I have to find the molar conductivity here. Calculate the molar conductivity of 0.01 m acetic acid solution. So I know one formula, this one, and I have one more formula for acid dissociation constant, C alpha square. Okay, so if I solve this, and I will get here alpha is equal to, so I am writing Ka for acid dissociation constant, root over of Ka by C. Now if this is my equation 1 and this is my equation 2, so I will get equating equation 1 and 2. So what I will get here, lambda m by lambda naught m is equal to root over of Ka by C. Okay, so then I'll just substitute the values here. Lambda m, lambda naught m is how much? 390.7. Okay, that is equal to root over of Ka is how much? 1.8 into 10 to the power of minus 5, and C is 10 to the power of minus 2, right? Okay, so yes, now if I solve this, you can just calculate this one, and here you will get lambda m value as 16.57 S centimeter square mole inverse. Okay, S centimeter square mole inverse. Okay, lambda m value will be 16.57 S centimeter square mole inverse. Okay, Next, question number 19. How many grams of chlorine can be produced by the electrolysis of molten sodium chloride, the current of 1 ampere for 15 minutes? Okay. Also calculate the number of chlorine molecules liberated. Okay. So this is again, I'll say little bit moderate question, not very direct formula based question. So first of all, how many grams of chlorine can be produced by the electrolysis of molten sodium chloride, the current of 1 ampere for 15 minutes. So if you see chlorine is like this, right? So how many grams are coming? 71 grams, right? Chlorine mass. So I can say that from 2 Faraday, okay, or 2 Faraday I will get 71 grams. 2 Faraday I'll get 71 gram, or not 2 Faraday, you can say charge. In terms of charge, if I talk, 2 into 96500 coulombs will give me 71 gram, right? Now 1 coulomb will give me 71 divided by 2 into 96500 grams. Okay. Now here how much charge I have or coulomb I have? If you see, 1 ampere for 15 minutes. Okay. So total charge I have here is 1 ampere into 15 minutes into 60 seconds. Okay. So that will give me 900 seconds, right? 900 seconds. So sorry, 900. So that will give me 900 coulombs. Yes, right. So now I can say that 1 coulomb is depositing this one. So from 900 coulombs, how much it will be deposited? 71 by 2 into 96500 into 900. So if I solve this, I will get this many grams. Okay, this many grams of chlorine will be deposited. Okay. Next, what is there or will be produced? Next, to calculate the number of chlorine molecules. So what I will do? Number of moles of chlorine, number of moles of Cl2. So given mass by molar mass, so that is 71 into 900 divided by 2 into 96500 divided by 71. This is the given mass divided by the molar mass. So how much I'll get? 900 divided by 2 into 96500. This is the number of moles. Now number of particles, okay, number of molecules. Number of molecules is what? Number of moles into Avogadro number. So 900 divided by 2 into 96500 into 6 into 10 to the power of 23. You can take it better 6, you have calculator, so we don't have to do any approximation here. So you can take 6.022 into 10 to the power of 23. Okay. So first we calculated here the mass, converted the mass into moles, and then converted them to number of particles. So if I solve this, okay, I will be getting this mass, we will get 0.331 gram. Okay, 331 gram will get, okay, and the particles we will get is 2.8 into 10 to the power of 21 molecules. Okay, you can do the calculation, you will find the same answer. Next, question number 20, I find very interesting and easy question as well, but yes, very interesting question. The lambda m values for NaCl and KCl are given to you. Okay, so I can write the molar conductivity of NaCl, which is equal to the molar conductivity of Na plus and the molar conductivity of Cl minus, that is equal to 126.5 S centimeter square mole inverse. Okay, so here some typing error is there in the unit, so please ignore it. Okay, next, next I have also for KCl. Okay, that is lambda of K plus lambda of Cl minus is equal to 149.9 S centimeter square mole inverse. Okay, now the ionic conductance of Na plus, okay, at infinite dilution is 50.1. So from here, can I calculate the molar conductivity of Cl minus, right? So I will use this one. See, in this equation, I am substituting, this is how much, 50.1 S centimeter square mole inverse, okay, then plus Cl minus is equal to 126.5 S centimeter square mole inverse, okay. Next, if I just subtract this one, okay, 126.5 and 50 minus 1, 5 minus 1 is 4, 6 minus 0 is 6, then 12 minus 5 is 7, okay. So 4 plus 1 5, 6 plus 0 6, 7 plus 5 12, so we will get this value. Next, calculate the ionic conductance of K plus. So now we have got this value, we have this value, and we have to calculate this value. So again, from this equation I can calculate lambda naught of K plus lambda naught of Cl minus 76.4 S centimeter square mole inverse is equal to 149.9 S centimeter square mole inverse, okay. So now we can subtract this one. So lambda naught of K plus is equal to 9 minus 4 is 5, right, then 9 minus 6 is 3, then 14 minus 7 is 7, 73.5 S centimeter square mole inverse, okay. So if I calculate this one, I'll get 73.5, okay, S centimeter square mole inverse. So please check the units, it is S centimeter square mole inverse. Okay, so we are done with the questions from electrochemistry. Now we will be proceeding to the questions of chemical kinetics. So students, now we will move towards the next chapter, that is chemical kinetics, and we will solve the questions from chemical kinetics, okay. So here some basic formulas are there and the questions are very easy. So the decomposition of N2O5 in CCl4 at 318 Kelvin was studied. Initially the concentration of N2O5 is 2.33 mole liter inverse, and after 124 minutes it was reduced to 2.08 mole liter inverse. The reaction takes place according to the following equation. Calculate the average rate of this reaction in terms of seconds. What is the rate of production of NO2 during this period? Okay, so this is a very simple question. So first of all, whenever you want to calculate the average rate, it is the change in concentration by the change in time, okay. So we can write like this: average rate is equal to change in concentration of the reactants by time. So now if you see, the change in concentration is 2.33 to 2.08. So I can write 2.33 minus 2.08 mole liter inverse divided by 184 minutes. So 184 minutes into 60 seconds, because we have to convert it into seconds, because question has asked you to find in terms of seconds. So if I solve this, I'll get the average rate, and the value that I'll get here is 2.26 into 10 to the power of minus 2, okay. Now rate, change in concentration of the reactant, unit is mole liter inverse, and time is second inverse, okay. Now see the next part of the question. What is the rate of production of NO2 during this period? So if I write the differential rate equation, then rate is equal to minus 1 by 2 dN2O5 by dt, okay, is equal to plus 1 by 4 dNO2 by dt, okay, is equal to dO2 by dt. Clear? Now if I want to find the rate of production of NO2, so if I just want to find dNO2 by dt, it is 4 times of the rate, right? So I can write dNO2 by dt, okay, is equal to 4 times of the rate, and rate I have already calculated, that is 4 into 1.26 into 2.26 into 10 to the power of minus 2. So if I solve this, I'll get 4 6 are 24, photosite 9, 10, photosite plus 1, 9, 0.04 into 10 to the power of minus 2. Okay, clear? Next, question number 2. Okay, here units are also required. Rate of, again rate is there, so the same unit, mole, liter inverse, second inverse. Okay. Question number 2 here. For the reaction R to P, the concentration of a reactant changes from 0.03 to 0.02 in 25 minutes. Calculate the average rate of the reaction both in seconds and in minutes you have to calculate. Okay. Here it is minute. What is the rate of production of P during this period? Okay. Same formula, average rate is equal to change in concentration of the reactant by change in time. So here, so if I want to calculate the average rate in minutes, so how much I'll get? Delta R is 0.03 minus 0.02 moles divided by time is how much? Time is 25 minutes. So if I solve this, I'll get 0.01 by 25. Right, so that if I solve it, so I can write 10 to the power of minus 2 by 25, right? So 1 by 25 is 0.04, I guess, right? Yes, 0.04 I'll get. So I can write it as 0.04 into 10 to the power of minus 2. Clear? Or I can write 4 into 10 to the power of minus 4. Clear? So this is your average rate in minutes. So how will I write? Moles, liter inverse, minute inverse. Okay. Now if you same thing you want to calculate the average rate in seconds, then it is 0.01 divided by 25 minutes into 60 seconds. So we have to solve this and we will be getting answer, that is I have already calculated in minutes. So for this one you can calculate in seconds. Okay, so I'll get like this, 4 into 10 to the power of minus 4, right, divided by 16. So I can write like this, 1 by 15 into 10 to the power of minus 4. Okay, so then you can solve this one and you can get the answer for this one also. Okay, so this one will come as 6.66 into 10 to the power of minus 6 mole liter inverse second inverse. Is it? Yes, 15 6 is 90, right? Yeah, that's why we will get. Okay, next is question number 3. The first order rate constant for the decomposition of N2O5 at 0 degrees Celsius is this much. So we have the value of rate constant, which is 5.2 into 10 to the power of minus 4 minute inverse. Okay. Next, if the energy of activation is 6200 joules, calculate the temperature at which the rate constant is 6.358 into 10 to the power of minus 6. Okay, fine. So this is from your Arrhenius equation. So we have a K1 value here, okay, and I can write another K2 value is okay, this is at 0 degrees Celsius, right? 0 degrees Celsius means I can write down at 273 Kelvin, T1, okay. And next I have 6.358 into 10 to the power of minus 6 minute inverse. So I can say that this is the lower temperature, so I can write this one as, see, I will take this one, the one with higher temperature as K2, this one as K1, okay, and this one is your T2 value. T2 is 273 Kelvin and I have to find out T1, okay. Next I have activation energy as 6200 joules. So now we can use the Arrhenius equation, log of K2 by K1 is equal to EA by 2.303 into R, T2 minus T1 by T1 into T2, right. So now I can substitute all the values. So I'll get log of K2 value is 5.2 into 10 to the power of minus 4 divided by 6.358 into 10 to the power of minus 6, okay, is equal to EA. EA is given to me 6200 divided by 2.303, right, into 8.314. Now this one is divided by T2, we have to know that is 273 minus T1 divided by 273 into T1. Okay, so I have to solve this and then I have to find the value of T1. So I can show you this one. I'll erase this because I have this answer in the form of this one. So you can see this is what you have to substitute, and then you can find the value of T2 value is 294.69 Kelvin. Okay. Yes, so this is the answer. So just do the calculation and then you can check the answer. Next, going to question number 4 here. The initial concentration of N2O5 in the following first order reaction, that is N2O5 gives 2 NO2 plus half O2, was 1.24 into 10 to the power of minus 2 mole liter inverse at 318 Kelvin. The concentration of N2O5 after 60 minutes was this much. Calculate the rate constant of the reaction at 318 Kelvin. So yes, it is already given. It is a first order reaction and we have to calculate rate constant. So we have to use directly the integrated rate equation for the first law, first order. So yes, what is the value of K I have? 1.24 into 10 to the power of minus 2 mole liter inverse, and initial concentration, sorry. So this is your A naught value. Okay. Next we have the concentration of N2O5 after 60 seconds. So time given is 60 seconds. Concentration of A is 0.20 into 10 to the power of minus 2 mole liter inverse. Then we have to calculate rate constant. Okay. So how can I calculate? K is equal to 2.303 by T log of initial concentration by final concentration. So that is equal to 2.303 by time 60 second log of A naught value is 1.24 into 10 to the power of minus 2 divided by 0.2 into 10 to the power of minus 2. Okay, clear? So now if I solve this, you can just solve all the values and find the value of K directly. We will get around 0.03 second inverse. Okay, so check the calculation. Next, coming to question number 5. Yes, this is important question, but I have solved similar question. The following data were obtained during the first order thermal decomposition of N2O5 at constant volume. Calculate the rate constant. So thermal decomposition of N2O5 reaction is given to us. So let me write down the reaction here. 2N2O5 gives 2N2O4 plus O2. Just a minute, let me remove this one. Yes, so plus O2. Now see, when time is 0, when time is equal to 0 means initial time, what is the pressure? The total pressure is 0.5, right? At that time this one is not produced, this one is not produced, so that is 0, 0. Next, time at 100 seconds. Okay, so at 100 seconds what happens? Suppose 2x will react from here, so 0.5 minus 2x, 2x has reacted means 2x will form and x will form here, right? So what is the P total? P total pressure, so it is 0.5 minus 2x plus 2x plus x. Okay, here you can write down P total means total pressure. Okay, now this total pressure according to the equation is how much? 0.512, right? Now this 2x and this 2x will cancel, so I will get x is equal to 0.012. Clear? ATM. Now I want to calculate pressure of N2O5, right, after 100 seconds. Okay, so that is 0.5 minus 2x, 0.5 minus 2x, and that is equal to 0.5 minus 2 into x value is 0.012. and if I get this one, so I can solve. 2 2s are 4, 2 1s are 2. Yes, so now if I get 10 minus 4 6, 9 minus 2 7 and 0.476, right? Yes, so I will get this much ATM, or the pressure of N2O5 after 100 seconds. Now if I use the K formula, K equal to 2.303 by T log of P initial by P final. Okay, P final means pressure of N2O5 after 200 seconds. After 100 seconds. Okay, so I can put 2.303 by 100 log of 0.5 minus 0.476. So if you just calculate this K value, you will get 4.91 into 10 to the power of minus 4 second inverse. So just check the calculation and let me know if you are getting the answer or not. Now coming to sixth question. First order reaction is found to have a rate constant. So K value is given to you 5.5 into 10 to the power of minus 14 second inverse. Find the half life of the reaction. So this is very simple formula. T half is equal to 0.693 by K, right? So that is 0.693 by 5.5 into 10 to the power of minus 14. So if I solve this, I will get 1.26 into 10 to the power of 13. Okay. This is easy question. Seventh one, a first order reaction has a rate constant is given. How long will 5 gram of this reactant take to reduce to 3 gram? So if you see, it is rate constant, it is also given you first order. So we can directly put the equation K equal to 2.303 by T log of A naught by A. So here we have 2.303 by T is how much we have to find out. So I can write T is like this, and K will be equal to 1.15 into 10 to the power of minus 3 log of A naught value is 5 and A value is 3. So if I solve this, I will get T value as 444.27 seconds. Okay. Next, question number 8. Time required to decompose SO2 Cl2 to half of its initial amount is 60 minutes. So I can calculate easily. K value is equal to 0.693 by T half, which is equal to 0.693 by 60 minutes. Okay. If the decomposition is a first order reaction, calculate the rate constant of the reaction. It is very simple. We can just calculate from here and you will get 0.01155 minute inverse. Okay, so simple formula based question. Now question number 9, the rate constants of a reaction at 500 and 700 Kelvin are 0.02 and 0.07 second inverse respectively. Calculate the value of EA. So this is a question from your Arrhenius equation again. So we have what? T1 is 500 Kelvin, T2 is 700 Kelvin, and then we have K1 0.02 second inverse and K2 0.07 second inverse. Okay, value of EA. So I can calculate like this: log K2 by K1 is equal to EA by 2.303 R into T2 minus T1 divided by T1 into T2. So just substitute the values here. Log of 0.07 by 0.02 is equal to EA by 2.303 into 8.314, and here I have 700 minus 500 divided by 700 into 500. Okay, so if I solve this and I calculate the value of EA, I'll get 18.22 kilojoule per mole. Okay. Next, question number 10. The first order rate constant for the decomposition of ethyl iodide by the reaction at 600 Kelvin is given, right? So we have temperature 600 Kelvin, and at that point what is the rate constant? I can write 1.6 into 10 to the power of minus 5 second inverse. its energy of activation is 209 into 10 to the power of 3 joules per mole. Okay. Calculate the rate constant of the reaction at 700 Kelvin. Okay, you have to calculate this one. So let us calculate log of K2 by K1 is equal to EA by 2.303 R into T2 minus T1 divided by T1 into T2. Okay, so now if I substitute log of K2, I have to calculate, okay, and K1 is 1.6 into 10 to the power of minus 5. EA is 209 into 10 to the power of 3 divided by 2.303 into 8.314, right, and T2 is 700 minus 600 divided by 700 into 600. Okay, so now if you solve this and check K2 value, if you calculate, you will get 6.22 into 10 to the power of minus 3 second inverse. Okay. Now coming to question number 11, the rate of the chemical reaction doubles for an increase in 10 Kelvin in the absolute temperature from 298 Kelvin. Calculate the EA value. Again it is same thing, so I can write that K2 by K1 is equal to 2, right, or just let us do like this. See, suppose K1 is equal to X, then what will be the value of K2? It is doubling, right, so it can be written as 2X. Here T1 is 298 Kelvin and it increases by 10 K, so that means it is 308 Kelvin. Okay, next we have to calculate EA. So just substitute this value, log of K2 by K1 is equal to EA by 2.303 into 8.314. Okay, so here I just have to not substitute the values, I just have to write the formulas. 2.303 R into T2 minus T1 divided by T1 into T2, right. Now if I substitute here, log of K2 is 2X, this is X, EA I have to calculate, divided by 2.303 into 8.314. Okay, now we have here 308 minus 298 divided by 308 into 298. So yes, we can solve this and activation energy will give to you 52.897 kilojoule per mole. Okay, now moving to question number 12. The activation energy for the reaction is 209.5 kilojoule per mole at 581 Kelvin. Calculate the fraction of molecules of the reactants having energy greater or equal to the activation energy. So in this Arrhenius equation, if you see, this is the Arrhenius equation, right? Now this term, okay, this term represents what? Fraction of molecules, fraction of molecules having energy greater than or equal to activation energy. Okay, now we have e to the power of minus EA by RT. I have to solve this, right? So you can just substitute e to the power of minus, what is the activation energy value? 209.5 into 10 to the power of 3 divided by R value is 8.314 and temperature value is 581 Kelvin. Okay, so now if I have this one, I will get around 1.47 into 10 to the power of minus 19. Okay. Next, question number 13. The rate constant for the first order decomposition of H2O2 is given by the following equation. Calculate the activation energy for this reaction and what temperature will its half-life be? 256 minutes. Okay. So here you can see that we can first calculate, this is log k. So we have this equation, log k is equal to log a minus EA by 2.303 r into 1 by t. Now the equation that is given to us is log k is equal to 14.34 minus 1.25 into 10 to the power of 4 by t. Okay, so what I can do is I can compare these two equations. You can say this is equal to this one, so I can write here that EA by 2.303 r is equal to 1.25 into 10 to the power of 4. So what is the value of EA now? So I can write down here, EA will be equal to, just multiply this one, 2.303 into 8.314 into 1.25 into 10 to the power of 4. That will give me EA value, and I will get that as 2.39 into 10 to the power of 5. Okay. Now the question is asking you at what temperature the half-life will be 256 minutes. Okay. So what is then K value? K value is 0.693 by T half. So how much is that? 0.693 by 256 minutes. So that will be equal to how much? We'll get 4.51 into 10 to the power of minus 5. So I have converted into 60 seconds. Okay. So 4.51 into 10 to the power of minus 5 second inverse. Okay. This I have calculated, that is the K value. Now I will substitute all the values here. See. So I have log of, next what I have to find out, the temperature. Okay. So log of K, that is 4.51 into 10 to the power of minus 5 is equal to log A, that is 14.34 minus 1.25 into 10 to the power of 4 divided by T. So solve this and you will get the value of T as 669 Kelvin. Okay, so just check the calculation. This log value you can directly calculate using the log table. This is there, and T is the temperature that you have to find out. Okay. Next, question number 14. Sucrose decomposes in acid solution into glucose and fructose according to the first rate law with T half as 3 hours. What fraction of the sample of sucrose remains after 8 hours? So here fraction of the sample is asked, means you have to calculate, see, this is there, right, K equal to 2.303 divided by T into log of A naught by A. So first I have to find out this value and then reverse it to get the fraction of molecules which remains after 8 hours. Okay. So this is the A value that remains after 8 hours and this is the total value, right. So I have to reverse this value. Fine. So K value I can find out, that is 0.693 by 3 hours into 2.303 divided by time is 8 hours, and here I have log of A naught by A, right. So how much will I get this one? So 0.693 into 8 divided by 3 into 2.303 is equal to log of A naught by A. Okay. Now if I solve this, A naught by A as 6.345. Okay. Now I have to calculate A by A naught because that is the fraction that is remaining. So A by A naught is equal to 1 by 6.345 and I'll get 0.158 here. Okay. So now if I solve this, this is the wrong answer. I'll get 0.158 as the fraction that is remaining. Okay. Now last, okay, that's all students. So we have solved so many questions. Now many of you might have a doubt on how to solve log and anti-log. So for that I'll be having a detailed video, so do not worry, just you have to practice these things, and log and anti-log how to find out, I'll make a detailed video on that. Apart from this, if you have any doubt in any question, please comment down, I'll definitely address. And remember, these time is very critical, so please do all the questions by your, just don't see and go to the next question, you solve it and check the answer whether you are getting it or not. Okay, that's all students, and all the very best for your exam.